really taken me into really where I am with building models and learning studies, but yeah.
Okay, this gives me a chance then to reintroduce Terry Boston, who will give his take on where we are and where we're going, and there may or may not be something to do with the dissertation you almost did, but Terry, go ahead.
I want to start out with kind of the history here of microgrids. As I mentioned this morning at 8 a.m., when the power is off, we don't go back to the 1980s. We go back to the 1880s, and I'll take you back there and kind of walk you through time very quickly. Thomas Edison invented the light bulb in 1878. He could not market it until he designed a distribution system in a microgrid. Chattanooga, Tennessee beat him to that with carbon arc lighting and a microgrid, and May 9th, 1882, we built the first microgrid, Chattanooga Brush Company, and I hung the 100-year plaque as an IEEE president in 1982. It was 25 lights in downtown and truly a microgrid. Pearl Street Station came in 6 months later. In downtown New York, it was an AC microgrid. Clearly, going back in the direction we started. Edison, an interesting factoid, the light bulb that I have the patent number on my tie here, he made more money with alkaline batteries than he did with the light bulb. He was in a race with Henry Ford. All the records that I didn't mention, the Association of Edison Illuminating Company, all the records of their debate about electric cars versus the 25 horsepower Model T are in the basement of Southern Company, and I have had the opportunity to open those records. They're in temperature control. We need to get it scanned in. Nikola Tesla came into the scene with a better mousetrap. We did not have ways to move DC long distances at that time, and we had a war of the currents between Tesla and Edison. The World's Fair, clearly Tesla won. AC could be stepped up in voltage and move long distances, and we built a Niagara power plant. We used 25 hertz, don't know why, but we came to a conclusion too much flicker, and we had moved it up to 60 hertz so that we couldn't see the flicker in the light bulb. Then Samuel Insull, assistant to Edison, came in and established this thing called a monopoly. You may have heard of that. It's more fun to play than poker. And moved to Chicago, and he named the company Middle West Utilities in Chicago. He went bankrupt, got blamed in part for the Great Recession of 1929, and I would add that many things happened very fast after that. In 1927, PJM was created. In 1933, TVA was created. TVA was to take an area of the country that was very, very poor and add electricity. The Rural Electrification Act came into play, much like we're dealing with the rural communication train as part of the IRA bill. But World War II came in, and electricity became very important to our industrialization. More improvements were made in the industrial sector and in aircrafts. We talked about that some this morning during World War II than any other time. And I'm going to take you through a decade at a time very quickly. The 50s and the 60s were all about coal. We built hydro during the war effort. The 70s were all about nuclear until 3 Mile Island, 1979. That kind of squelched that. The 1980s were all about nothing. We had a recession, we were overbuilt, and we didn't have a lot of generation. The 1990s, we came up with this neat idea of combined cycle natural gas with the topping cycle of steam, and it was all about natural gas. 2000 to 2010, 2010 was a little bit like the 1980s. We didn't build a lot of generation out, we had lots of plans. Then we were building LNG imports. Now we're using those same terminals and doing LNG exports. But I wanted to mention that we did build out a huge fleet in 2010 through 2015 of MPJM along 30,000 megawatts of natural gas combined cycle plants. We badly need to be able to do carbon capture and storage and save that from being high stranded costs. And 2015 through 2023 is all about renewables and batteries. We have a very balanced portfolio brought to you 10 years at a time with my optic focus on one fuel type. Going forward, if we shutter all the coal plants, it's going to be a real challenge. Decarbonization is going to put more stress on the grid. So reliability, resiliency, and robustness leads us to the need for critical functions, not everything, but critical functions to move to microgrids. And thank you for hanging with me through the history of electricity.
And in honor and protection of your reputation, remember, he hung the plaque in 1982. He wasn't there in 1882, right?
1982, 100 years after.
That's it.
Well, picking up on the history story, and it's funny that Chattanooga's claiming the first, and I live in Colorado, Telluride claims some kind of first as well. So everybody wants to be first.
Where was it?
I think Chattanooga beats it, but so Telluride is claiming the first something else, but in the 1880s. Anyway, but let's talk about microgrids, because they aren't a new thing. I'm not going to go all the way back to the 1800s, although surely those were microgrids. But we were doing microgrids in the 90s, but then it was really about rural areas in developing countries. What's now called energy. We call it village power. It's now called energy access. But those, and they call them mini grids instead of microgrids, which is kind of an abusive language because these are tiny. Typically 10 to a few hundred kilowatts, whereas microgrids you're talking about are tens of megawatts. In my world, micro should be smaller than mini, but that's not the case in this case. Anyway, there's a lot of experience and expertise that was developed through that work. And in addition to the reliability and resilience that we're mostly focusing on, one issue that we really learned about back then was how to do renewables at very high penetration. So there are mini grids, microgrids, whatever, on islands that are 99% renewable. Tokelau is a tiny little island in the Pacific, 99% renewable. Kodiak, Alaska is not that tiny. It's the largest Coast Guard base in the U.S. It's the home of the fishing fleet from Dangerous Catch. You might have seen that TV. And they're 98% renewable. And they have some interesting storage that, in addition to hydro and wind, and they also have flywheels in addition to a battery. So and they've learned how to manage a system entirely on inverter-based power electronics, no rotating equipment except maybe a synchronous condenser. And so this is learning that the big grid will take advantage of, but it's been pioneered and perfected on mini grids and microgrids around the world. I was just a couple of months ago in the Faroe Islands, which are in between Iceland and Norway. Phenomenal wind resource up there, running 100% renewable. Not all a year, but the whole time I was there anyway. So that's another real value stream, value proposition for mini grids and microgrids, in addition to providing power where it can't be provided any other way, providing reliability and resilience at a level that the big grids simply can't do, but also demonstrating that you can do renewables at high penetration and and you can maintain stable power systems with power electronics, energy storage, load management, working together to create a stable utility system in ways that we're going to need for the larger grid as well. So the other thing I might say before I hand it over to the mic is that if you've seen one microgrid, you've seen one microgrid. They're all different. It's, you know, the analogy to how quickly that it was brought up yesterday, I think, about the Model T and how quickly the world changed from horses to cars because we had a Model T. You know, you get any color you want as long as it was black. And if we had that kind of cookie cutter one-size-fits-all solution, it'd be wonderful, but we don't. That's why we created the Homer software, so that you could figure out, okay, for my situation with my loads and my resources, what's the right configuration? And so there's a design challenge that's what we're all working on. So I'll pass it on.
Thank you. In keeping with the history lesson when Washington crossed the Delaware, that's way too far back, sorry. Sitting here speaking about microgrids, I'm going to talk mainly about the Navy Marine Corps, what we call DON, Department of the Navy, because the Marine Corps is a Department of the Navy, it's the men's department, but still the Department of the Navy. But also talking about the Army and the Air Force. My compatriots were invited here, but they decided not to come, so you guys got to give them a hard time if you see them. The Navy has really embarked upon the microgrid thought process to add the resiliency. And I'm going to take a little bit of a different approach than most of the other people up here because, as I said, my mission is to make sure that the weapons system can go out and do its mission. You know, whether it be a carrier going out there, a plane taking off, a sub sinking, a tank going out into the battlefield, whatever it is, the shore establishment has got to be there to support that. Not only the weapons system, but the people who work it. You know, the people behind the weapons system are as important. So we look at it from a standpoint, if we can't do our critical mission, why are we even here? So microgrids are going to be very important to our system of operations. The Assistant Secretary of the Navy for Installations and Energy Installations and Environment, EI&E, has come out and indicated that all critical infrastructure within the Navy, and it's a classified number, but it's out there, shall be on a microgrid by 2035. It's a pretty tall order since has been articulated. You've seen one microgrid, so that makes design, engineering, installation, construction, but what most people forget is the operation, maintenance, and sustainment. That's the critical point that we look at from a life cycle cost analysis of putting microgrids onto every single one of the Navy critical infrastructure. Same with Marine Corps. The Army has a little bit of a different philosophy. They want the microgrid on every single installation. They have 132, if my memory serves me correctly, installations around the world. I only have 100 between the Navy and the Marine Corps, and the Air Force, I'm not even sure has how many. But the Army has said they want a microgrid on every single installation. And the Air Force is kind of between the DON and the Army. So it's important to us. It's important to DOD, OSD, and if I slide into acronym soup, somebody raise their hand, I don't understand that one. But Office of Secretary of Defense has said microgrids is the way that we go forward. But as my compatriot showed this morning, one of the important infrastructure aspects is if you have poor infrastructure, which unfortunately to say, most of our military installations are 80 years old or older, and the maintenance on those is getting harder and harder. If you have poor utility infrastructure, microgrid's not going to fix it. And microgrid is the load determination, split loads, you take your DER, you have some control structures. But if you have poor utility infrastructure, it's really not going to help it. So that's something that we are kind of struggling with a little bit right now on ensuring that we have adequate power out there. The reason I go through that is, vision. There's a lot of vision out here vision without resources is a hallucination. So if you don't have the resources, and that's not only money, money is a big part, don't get me wrong, but it has been brought up, the people, the equipment, the technology, leveraging the technologies that's out there, all important aspects to go forward to make sure, again, my mission, my success is to make sure that that warfighter can go out to the tip of the spear and have fun. So with that being said, you know, we in the military, and I'm speaking for the Army, Navy, Air Force, Marines, only because I know them all, and we do traveling circuits here. We are wanting and needing you all, the outside influences, the engineers, the architects, the smart people out there, the 20-pound heads, to help us. Again, our mission is to go out there into harm's way. We really depend on the communities, the industrial base, the commercial entities that are out there to help us get to that success. So it's not